Why do some carbon fiber bicycle frames have a wrinkly appearance despite a solid and smooth outer shape that feels good to the touch? And are they safe to use? My name is Drew. I run Regular Cycles LLC. I build carbon stuff. Let's get into it. Instead of talking shit about other companies, I'm going to pick on my own work. This is a part I rejected, something I made in 2022. There's the light angle that I need. You see those wrinkles in between my thumb and index finger? They're not supposed to be there. That's a flaw. And it's strong enough to use, but people are going to ask, is that okay? I don't even want to have the conversation. That's why I disqualified it from sending it out. These days I use twill carbon fabric at the surface layer. It's much easier to manage the wrinkles, and it has a strength benefit in terms of damage or striking damage resistance. So, why does this wrinkly stuff happen with so many mass manufactured UD prepreg carbon bikes? What does that jargon mean, and what can be done about it? Let's talk first about UD prepreg. Unidirectional is what UD stands for. It's fiber going in one direction. This is an example of one cause of wrinkling. It came from the manufacturer this way. I was not pleased. Hardly ever happens, so don't worry too much about that. Essentially, the resin system is included into the fiber stack. That's why these loosely oriented fibers are even able to stick to each other. I'll give you an example of what happens if you just end up being a little mean to it. You can peel it apart really kind of dramatically. So you need to be careful in even working with this stuff at all, because introducing wrinkles is way too easy. But put that out of your mind, because it's a lesser extent. A bigger problem is laminator error. With composites in bicycle applications, it's really hard to get any kind of small diameter curvature. These stiff fibers don't like to bend. And UD specifically is for having a cosmetic finish that is muted compared to the excitement of twill. This looks ostentatious, this does not. Many companies want the less exciting version, but it's so hard to conform, so difficult to conform into a cavity. Here, check this out. It's in a slippery mold, doesn't really want to stick, and it doesn't go in the way you'd think. It twists, and that has to do with the fiber stiffness. You kind of have to feel it to believe it. But it is profound. So it's hard to do at speed of mass manufacturing, of getting them the contact ply right up to the cavity edge of the flange in a convincing way where the helix goes around so that it makes a consistent color all across the length of the bar. It's very difficult to do. So the third cause doesn't necessarily have to do with laminator skill at all. Sometimes it is a tooling problem, and that's what happened with this bar in particular, is the entire length of the bar from end to end shrunk from one cavity edge to the other, because we're going to pretend that my pinky finger is the bladder that inflates from the inside out of a preform. It moved across the length. Instead of increasing the cross-sectional diameter, it shifted. And sometimes, instead of gently kind of going across or inside the length of the preform, sometimes it'll catch and it'll drag the end along with it. And this can have exotic effects in terms of lifting fiber off from a cavity elsewhere, or pulling it tight in some cases and lifting it off. Or in this case, it tried to wrinkle the entire thing. What do you get when you push on a string? You get a wrinkle in the weakest spot. No big deal, everybody knows that. What do you get when you push on a bunch of strings that are more or less glued to each other but not yet solidified? You get wrinkling all over the place. This entire thing is wrinkled. Wrinkled there. As I roll it, you can see dimples. Not good. So again, the part of why I use twills, it just solves a lot of those problems. But what can be done to avoid bladder migration? You need a better inlet than what I had at the time. This is one of my more modern inlets. Basically, I'm tapering the addition of layers. You can see how this kind of delineates, and then there's a layer here and a layer here and a layer here. I'm basically adding thickness as this taper is changing, and it prevents the shaping problems of finicky little ends of prepreg segments. It prevents these little hooks from occurring, and you get something that's more of a consistent hoop so that you don't have anything to catch up on. So that's one way. Another way is to just avoid the difficulty of putting these things in all stupid like, and how much time that takes to match them up exactly to the flange. You can instead pair up UD, but you have to get them exactly on, otherwise you'll have color differences, right? and that can show up in the molding, where even if you have an outer helix of maybe 45 degrees that looks complete, it's really in the shape of a C, or kind of two arcs of different sizes. If they don't have enough excess of length around the exterior, it can grow a little bit and kind of do peekaboo, where it shows the second layer and it goes from gray to black or black to gray depending on the angle of the lighting. So aside from pairing up and getting exact cuts and exact placements, which is very fussy, there's another method that can be used. So aside from the prepreg stuff, there's dry fiber. This is dry twill fabric. It also comes in unidirectional with a stitching that makes things look ugly, but you have to add resin yourself. And I use it sometimes. And Time Bicycles uses it a lot. And what they do, we're going to pretend for a moment that this lever is going to be an air chamber at some point, like an air chamber that makes up the interior of this bar at the end of its manufacturing. We're just going to assume that by some bullshit magic this won't exist anymore after you're done using it. Time uses wax. They use a wax core, and what you can do is basically, instead of trying to jam your finger, which you can't change the size of, and it will give you nerve damage on your fingertips if you do it all day. Ask me how I know. It'll also give you tendonitis if you back bend your finger all freaking day. That's not good for it. Instead, if you have a convex form, you can mash it, right? You can really get in there. It takes the shape really easily. You can use all your fingers. You can switch up your fingers to take breaks, and critically you can use your thumb in a backstroke kind of way to stretch out the overall shape and lengthen it, and you get a result that more or less resembles your curvature. And I'll lift this off carefully, the interior has minimal wrinkling that can be taken up by the end. It's all like uniformly distributed wrinkling, and this is a very thick example, so this drastically exaggerates what's happening. Usually I'm using thinner layers than this, but this is a small batch of stuff that I have to discard because it's 4 years old and it has no application for real life bike use. But the Time method of basically having a convex form and they melt out the form after the fact to achieve an air chamber, it can be informative for working with prepreg. You can't use wax for the core because the heating process of solidifying the prepreg is going to melt the wax before it finalizes the prepreg shape. So that's not viable. So what some companies do is they make sort of like a shell, and the bladder goes in that shell and the carbon goes around that shell, so it's an interior shell, which is a strange name. But it basically accomplishes this same sort of thing by having a multi-tiered system of materials, and you get these various flaws that sort of cancel each other out, and it's a pretty good system. I think Parley did it at some point, and I believe that Felt did it at some point. I use a method, I'm not going to picture it here, it's a long conversation. I actually make separate thin candy shell carbon structures that end up being the interior layer of the air chamber of the finished part. It just joins up with it. It only adds 5 grams. They're really, really hard to make. But it just sticks in with the whole thing, and then I just pull the bladder out, confident in the knowledge that the length of it has maintained the original value as when the preform went into the mold, and that it only grew in diameter and not changed in length. And incidentally, the reason I'm using carbon fiber for my molding process is a thermal matching intent. It just goes in, and during the baking process it changes shape a little bit, but critically, because they're made of the same material for the component and the mold, when it cools down they shrink at the same rate, so the part just comes flopping out at the end of the day. And that's why my flashing in many cases is so minimal. This is kind of what it looked like coming out after I just knocked off things with a razor blade real quick. So that's kind of the quick and dirty of why you sometimes see frames with wrinkles like this. What do you need to know from a safety perspective? You really need to look out for sudden color changes. I've made this wrinkly piece just as an exaggeration of what you might see under the surface. You see how there's a very clear ledge, but looking on, it all might be a pretty similar orientation, but you'll see a black line in the middle of it. If you see what is otherwise a consistent, or maybe even just a little lumpy feedback with some eventual changes in tone, that's fine. But if you see a sudden black line going across it, or maybe at a shallow angle, that could be a serious strength risk, and you should reach out to the company and ask them, is this a serious issue? Some dude on the internet told me that maybe it is. I hope you found that helpful. I'm not here to talk shit about other companies because mass manufacturing is very difficult, and I don't really want to prey on people who maybe don't have a good financial incentive to do good work. But maybe you found this educational, maybe not, and if not, I'm sorry for wasting your time. My name is Drew. I run Regular Cycles LLC. I build elite carbon structures in my garage. It's what I do for a living. Call me crazy. My website is www.regular.bike. As always, keep the rubber side down and have a good ride out there.